Southwire's AP products offer several potential benefits, primarily the elimination of the green ground wire. These cables utilize an aluminum number 10 ground wire that runs inside the cable, maintaining continuous contact with the armor. This design removes the necessity of terminating the ground wire within the electrical box. No more using separate grounding connectors or wire nuts. The armor itself serves as the grounding path. These cables require the use of approved connectors, boxes, and self-grounding devices to ensure proper functionality and safety. The Underwriters Laboratories, or all, the Canadian Standards Association, or CSA, and Intertek have approved these products, indicating they meet established safety and performance standards. Despite these approvals, some objections might arise concerning the use of aluminum for grounding. Some jurisdictions do not permit any aluminum in their jurisdiction. Concerns about oxidation and corrosion of aluminum are potential reasons for this resistance. Inspectors unfamiliar with AP cables may initially reject them. Education is crucial for overcoming objections. Informing inspectors of the product's approval status and associated benefits can help alleviate concerns. Demonstrating how the products work and showcasing their compliance with applicable codes can provide further reassurance. Coordinating with local code officials to discuss the use of AP cables and obtain their approval is a proactive approach. Using connectors, boxes, and self-grounding devices specifically approved for use with AP cables is essential. Southwire's AP products can streamline electrical installations. They reduce labor costs and enhance safety. While initial resistance from inspectors is possible, educating them about the products and their approval status is important. Working collaboratively with inspectors and code officials can pave the way for widespread acceptance and the realization of these products' full potential. The key considerations for using Southwire's AP cables effectively are: firstly, understanding the product's features and benefits; secondly, being aware of potential objections and how to address them; thirdly, ensuring compliance with applicable codes and standards; fourthly, using approved components; and fifthly, collaborating with inspectors and code officials. Aluminum grounding is a critical aspect to understand. While aluminum is a good conductor of electricity, it is susceptible to oxidation. Aluminum oxide is a poor conductor, which can compromise the grounding path over time. However, the design of AP cables mitigates this risk by ensuring continuous contact between the aluminum ground wire and the armor. This continuous contact helps prevent oxidation and maintains a reliable grounding path. Furthermore, approved connectors and devices are designed to create a secure and corrosion-resistant connection between the cable and the electrical system. Proper installation techniques are also crucial for ensuring the long-term reliability of aluminum grounding connections. The National Electrical Code, or NEC, provides guidelines for grounding and bonding electrical systems. Adhering to these guidelines is essential for ensuring the safety and performance of electrical installations. Specific NEC sections address the use of aluminum conductors and grounding requirements. For example, NEC Section 250.118 outlines acceptable grounding conductors, which may include aluminum under certain conditions. NEC Section 250.120 addresses the grounding of electrical equipment. It specifies the requirements for grounding conductors and bonding connections. When using AP cables, it is important to consult the manufacturer's instructions and the NEC to ensure proper installation and compliance with applicable codes. Self-grounding devices are designed to establish a grounding connection through the mounting screws or clips. These devices are commonly used with metal boxes to provide a reliable grounding path. However, it is important to ensure that the box is properly grounded to the building's grounding system. The grounding electrode system typically consists of a ground rod, a metal water pipe, or a concrete encased electrode. The grounding electrode system provides a connection to earth, which helps to stabilize the voltage and provide a path for fault current to flow back to the source. The size of the grounding conductor is determined by the size of the service entrance conductors. NEC Table 250.166 provides guidance on the minimum size of grounding conductors based on the size of the service entrance conductors. Bonding is the process of connecting all metal parts of the electrical system together to create a low impedance path for fault current. Bonding helps to reduce the voltage between different metal parts, which can minimize the risk of electric shock. NEC Section 250.96 specifies the requirements for bonding metal enclosures and equipment. When using AP cables, it is important to ensure that all metal boxes, enclosures, and equipment are properly bonded together. Surge protection is another important consideration for electrical systems. Surge protective devices, or SPDs, are designed to protect sensitive electronic equipment from voltage surges caused by lightning or other transient events. SPD are typically installed at the service entrance and at branch circuits. NEC Section 285 provides guidance on the selection and installation of SPD. When using AP cables, it is important to ensure that SPD are properly installed to protect the electrical system from voltage surges. Electrical safety is paramount. Always to energize circuits before working on them. Use appropriate personal protective equipment, or PPE, such as gloves and safety glasses. Follow lockout-tagout procedures to prevent accidental energization of circuits. Only qualified electricians should perform electrical work. Improper electrical work can be dangerous and can lead to electric shock, fire, or other hazards. Regular electrical inspections are important for identifying potential problems and ensuring that the electrical system is safe and in good working order. Electrical inspectors are trained to identify code violations and other safety hazards. Addressing these issues promptly can prevent accidents and ensure the long-term reliability of the electrical system. Continuous education is essential for electricians and other electrical professionals. Staying up to date on the latest codes, standards, and technologies is crucial for providing safe and effective electrical services. Numerous resources are available for electrical education, including trade schools, online courses, and industry publications. The National Fire Protection Association, or NFPA, offers a variety of training programs and resources for electrical professionals. The Independent Electrical Contractors, or IC, and the National Electrical Contractors Association, or NECA, are also valuable resources for electrical education and training. We remember that electrical codes and standards are constantly evolving. Staying informed about these changes is essential for ensuring compliance and providing safe electrical services. Consulting with local code officials and industry experts can help clarify any questions or concerns about electrical codes and standards. By prioritizing safety, adhering to codes and standards, and continuously seeking education, electrical professionals can contribute to the safety and well-being of the community. Furthermore, consider the specific application when selecting electrical cables. Factors such as voltage, current, temperature, and environmental conditions should be taken into account. Different types of cables are designed for different applications. Using the wrong type of cable can lead to premature failure or safety hazards. Always consult the manufacturer's specifications and applicable codes to ensure that the correct type of cable is selected for the application. Proper cable management is also important for ensuring the long-term reliability of electrical systems. Cables should be properly supported and protected from physical damage. Avoid running cables in areas where they may be exposed to excessive heat, moisture, or chemicals. Use cable trace conduits or other protective measures to protect cables from damage. Proper cable management can also help to prevent electromagnetic interference or EMI. EMI can disrupt the operation of sensitive electronic equipment. Shielded cables and proper grounding techniques can help to minimize EMI. When installing electrical cables, it is important to follow the manufacturer's instructions carefully. Use the correct tools and techniques to avoid damaging the cables. Avoid over-tightening connectors, which can damage the insulation and lead to electrical shorts. Always test the completed installation to ensure that it is working properly. Use a multimeter or other testing equipment to verify that the voltage, current, and resistance are within acceptable limits. Careful installation practices can ensure the long-term reliability and safety of electrical systems. Understanding the principles of electrical theory is essential for anyone working with electrical systems. Ohm's law, Kirchhoff's laws, and other fundamental concepts provide the foundation for understanding how electrical circuits work. A solid understanding of electrical theory can help to troubleshoot problems and design effective electrical systems. Numerous resources are available for learning about electrical theory, including textbooks, online courses, and training programs. Investing in electrical education is a worthwhile endeavor that can lead to a rewarding career. The electrical industry offers a wide range of opportunities, from residential wiring to industrial automation. With the right training and experience, you can become a skilled electrician, electrical engineer, or other electrical professional. The demand for qualified electrical workers is expected to grow in the coming years. As technology continues to advance, the need for skilled electricians and electrical engineers will continue to increase. A career in the electrical industry can provide a stable and rewarding income, as well as the opportunity to make a positive impact on the community. By providing safe and reliable electrical services, electrical professionals play a vital role in our modern society. In addition to technical skills, soft skills are also important for success in the electrical industry. Communication skills, problem-solving skills, and teamwork skills are essential for working effectively with customers, colleagues, and other stakeholders. Strong communication skills are important for explaining technical concepts to non-technical audiences. Problem-solving skills are essential for troubleshooting electrical problems and finding effective solutions. Teamwork skills are necessary for collaborating with other professionals on complex projects. Developing these soft skills can enhance your career prospects and increase your earning potential. The electrical industry is a dynamic and challenging field that offers numerous opportunities for personal and professional growth. By staying informed, continuously learning, and developing your skills, you can achieve success in this rewarding industry.